Welcome to another lab session. In this exercise, we will be using cantilever beams to calibrate strain gauge output. The apparatus involves the use of several different components. First, we have our cantilever beam instrumented with one single strain gauge located at the top of the cantilever beam. The strain gauge will be configured in a Wheatstone bridge configuration using three 350 ohms dummy gauges. Thus, we will have a quarter bridge configuration. The intranet software on the CPU converts the bridge voltage output directly to microstrings. So the complete apparatus in this experiment will be using our CPU, our intranet data acquisition system, our cantilever beam instrumented with one strain gauge, along with 5 100-gram weights. We'll be also using our vernier caliper to take the dimensions of the beam, and we'll have 3 dummy gauges and our bridge completion box. The procedure will be as follows. We would first locate our diagram for Wheatstone bridge configuration that would illustrate the format that the strain gauge should be connected to the intranet data acquisition system. So let's take a closer look at that. The diagram represents the Wheatstone bridge configuration, and this resistor represents the active strain gauge located on the top of the beam. And these 3 resistors represents the 3 completion resistors, which can be seen in our circuit completion box. So this would be our active strain gauge, and these will be our 3 dummy resistors. We would then take measurements of our cantilever beam using a caliper, a vernier caliper, taking the width, thickness, and also the length of the beam. We would also take note of the location and distance of the strain gauge on the top of the beam, and that's the distance from the clamped end to the center of the strain gauge. Next, we would then look at the intranet software on the CPU to make sure readings are being transmitted, and we would ensure that the strain measurements are within the scale provided by the software. Our scale measurement can be seen from here to here. After configuration is complete, we would then apply loads in increment of 100-gram weights. A minimum of 5 different loads should be applied to the beam, and deflection at each load application recorded. During each load application, we will be observing and recording the strain reading of the beam through the intranet software. Now let's begin the experiment. So the system is configured and we're ready to go. So we would first take our 0 reading with no loads on the cantilever beam, start, and save at 0 load. Then we will apply our first load of 100 grams, allow the vibration to settle, then start and save at 100 grams. Next, we would apply our second load of 100 grams, bringing the weight up to 200 grams. Then take readings, save at 200 grams. Next, we would apply our third load of 100 grams, bringing our weight up to 300 grams. Start and save our 300 grams. Now we move on to our fourth load, bringing our weight up to 400 grams. Then we would hit start and save that data at 400 grams. Then we would take our last weight of 100 grams, bringing it up to a grand total of 500 grams. And we'll take readings and save at 500 grams. And at this point, we would have 6 readings: 0, 100 grams, 200 grams, 300, 400, and 500 grams. So at this point, the experiment is complete. Your data will be transmitted by your professor.